Okay. So, question number one: which of the following is not a unit of mass? Metric ton, atomic mass unit, millinewton, or quintal? Metric ton again we use for measuring the mass. Atomic mass unit, which gives you the mass of an atom, and quintal is again used to measure the mass of a material. Millinewton is not a unit of mass, hence the correct option is C, millinewton. Okay, next question number two: which one of the following is not a unit in the SI system? That is the system international system. So Farad, Poise, Pascal, and Tesla. Farad, it is a SI system. We use to find the capacitance of a capacitor. Pascal, we use that Pascal in order to find the pressure. Then Tesla, again we use the unit to find the magnetic field, the power of the magnetic field. Then again we have Poise. Poise is a CGS system, which is in CGS system. It does not comes in SI system. Hence Poise does not belong to the system international. So Poise is the correct option. The total surface area and the volume of a cube are found to be equal in magnitude. What is the volume of cube if the length of each side is measured in centimeters? Okay, so here we have given something, that is the total surface area and the volume are equal in of a cube. Both are equal to each other. Okay, so first we'll have the volume of a cube, which will be equals to the length cube. Okay, and we have the total surface area. So total surface area, the formula is 6 times the length square. Okay, and we have given the total surface area and the volume of a cube are found to be equal. So L cube is equals to 6L square. So what you get is L equals to 6, right? So that will be 6 centimeter. What we need to find is what is the volume of the cube if the length of each side is measured in centimeters. What is the volume of the cube if length of each side is measured in centimeters? So the volume of a cube will be equals to length cube, and length we have is 6 cube, that becomes equals to 216 centimeter cube. Okay, so the correct option is B, 216 centimeter cube. 1 micron is rated in centimeters as 1 micron equals to 10 raised to minus 8 centimeter, 10 raised to minus 5 centimeter, 10 raised to minus 6 centimeter, 10 raised to minus 4 centimeter. Okay, so here we have 1 micron is equals to, the micron term goes to minus 6 in meters, in terms of meters, and we know 1 meter is equals to 10 raised to 2 centimeters, right? So that will be 1 micron is equals to 10 raised to minus 6 into 10 raised to 2, so that becomes 10 raised to minus 4 centimeters, that is 1 micron. Okay, so the correct option is D, 1 micron is equals to 10 raised to minus 4 centimeters. Next, the SI unit of temperature is, temperature as we know it is measured in 3 scales, degrees, kelvins, and Fahrenheits. So only we have the SI unit of the temperature is to be Kelvin. Okay, it is not the degree Kelvin, it is just Kelvin. Which of the following units are correctly expressed? Meter, Newton, joule, second. So while we write a name of an unit in full letter words, your first letter should be a small letter according to the rules of the writing a unit. Okay, so the rule says that your first letter should be a small letter, and here as we can see, the meter, like M is capital, the N is capital, the joule is also capital, the N is small out here. So Newton is expressed correctly in the following 4 units. So the SI units of Planck's constant is, Planck's constant H is joule second square, joules per second, joule second square, or joule second. Okay, so we have Planck's constant as H. We generally use to find the energy emitted by the photon, which is given by H into mu, where mu is the frequency. If we keep the H on one side, we get E upon mu. Mu being the frequency, 1 upon mu is equals to time. So we get energy multiplied by time, which is equals to H. Energy is measured in joules, time is measured in seconds, so the Planck's constant is measured in joules seconds. Okay, what is the relation between one astronomical unit AU and 1 parsec? So this is the relation, 1 AU upon 1 phi equals to 5 seconds, 1 AU upon 1 p upon 1 second, 1 AU upon 1 p equals to 3 seconds, or 1 AU upon 1 p equals to 0.1 seconds. Basically, the relation between an astronomical unit and a parsec is that 1 parsec will be the distance in which an arc of 1 astronomical units, it will make an angle of 1 second. Okay, that means if there is a distance, if there is the distance between of 1 parsec, then the arc, which whenever there will be an arc of 1 astronomical unit which it will make by forming a degree, and that degree will be 1 second ka angle. Okay, so your in order to measure the arc, what you have is, in order to measure the angle, this angle which you will be given by the arc upon the distance, that is arc upon the radius, right? So that is given by angle. The angle you are forming is of 1 seconds, that is equals to arc is 1 astronomical unit upon the radius is called as 1 parsec. This is the relation. So your correct option is B, that is 1 astronomical unit upon 1 parsec is equal to 1 second, that is 1 second of an arc. Okay. Okay. How many meters are there in a light year? 6.5 into 10 raised to 15, 7.6 into 10 raised to 15 meters, 9.46 into 10 raised to 15 meters, 3.8 into 10 raised to 14 meters. So here we know the speed of light, that is equals to 3 into 10 raised to 8 meter per second. So if a light is supposed to, so for 1 light year, the definition goes that such as the distance traveled by the light in 1 year. So distance traveled in 1 complete year. So we have distance travel, so that means by which speed it is going, is it is been traveling. So the speed of the light multiplied by the time, we know the distance formula, that is speed multiplied by the time taken. Okay, the speed it has been traveling with the speed of 3 into 10 raised to 8 multiplied by the time it takes, that is around 1 year. So that gives you 365 days multiplied by 365 days multiplied by 30, that is the 30 days of a month, multiplied by 60 minutes multiplied by 24 hours multiplied by 60 minutes multiplied by 60 seconds. Okay, so the entire calculation, it comes out to be 9.46 into 10 raised to 15 meter. Okay, so this is the distance the light will cover within 1 year, that is called as the 1 light year, that is 9.46 into 10 raised to 15 meter. Okay, 2 into 10 raised to minus 12 meters can be expressed as 2 picometers, 2 picometers, 2 nanometers, 2 terameters. So we'll give a unit scale for all this, that is a peta, that gives you 10 raised to 15. Okay, and if you have nano, that will be about 10 raised to minus 9, very small. Next, if you have pico, that will be 10 raised to minus 12, even smaller. And if you have tera, it will be 10 raised to 12. So now your unit here is given as 2 into 10 raised to minus 12. So the minus 12 goes for the pico, so it can be written as 2 picometers. Okay, parsec is a unit of time, distance, frequency, or angular acceleration. Parsec basically is a unit which is used to measure the distance between the two stars. Okay, it is defined as an arc of a length which is equal to an astronomical unit and which forms an angle of 1 second. So parsec is basically a unit to measure the distance. Okay, so the correct option is B, distance. Okay, how will you express the number 434100 in power of 10? So if we need to express this in power of 10, 434100, okay, so we need to move the decimals from from the right to the left. Okay, so we move the definite decimals from right to the left, from up till we get a point out here. So we have to move some places. Let's see how many. If the point initially is here, so 1 2 3 4 5 6, so to get 4.341000, we have to move 6 decimal places. That means we have to multiply this number by the power 10 raised to 6. So we can write 4.341 multiplied by 10 raised to 6. Okay, so B is the correct option. What is the order of magnitude of the following sum, that is 10 raised to 4 plus 10 raised to 2? So for 10 raised to 4 we have 1 2 3 4 zeros. For 10 raised to 2 we have 2 zeros. After adding we get something like 10100, right? So its order of magnitude is 10 raised to 4. So total order of magnitude of the entire sum is 10 raised to 4. Question: the astronomical unit is the distance between the earth and the sun. 1 u is equals to 1.496 into 10 raised to 8 kilometers, 3.084 into 10 raised to 13 kilometers, 9.46 into 10 raised to 12 kilometers, or 4.596 into 10 raised to 15 kilometers. Basically, one astronomical unit, that is the distance between the earth and the sun, is measured as 1.496 into 10 raised to 11 meters, but in kilometers it turns out to be 1.496 into 10 raised to 8 kilometers. So your correct option is 1.496 into 10 raised to 8 kilometers A. Now, the ratio of the volume of the atom to the volume of the nucleus is of the order 10 raised to 10, 10 raised to 15, 10 raised to 20 or 10 raised to 25. So firstly, we'll take the volume of the atom and then the volume of the nucleus and we'll find the ratio. So volume of the atom is 4 by 3 pi r cube, as the radius of the atom is 10 raised to minus 10 meters, so it becomes 10 raised to minus 10 raised to power minus 10 raised to 3. Okay, so volume of the nucleus is again 4 by 3 pi r cube, as the radius of the nucleus is 10 raised to minus 15, the whole cube. So we'll take the ratio of both of them, 4 by 3, 4 by 3, pi gets cancelled, and we are left with 10 raised to minus 30 upon 10 raised to minus 15, which on solving we get the value of 10 raised to 15. So B is the correct option, 10 raised to 15. Diameter of the circular ring is 6.28. What is the circumference taking into account the significant figures? Okay, so the diameter is equals to 6.28 meters. Okay, so the radius is equals to 6.28 upon 2, that will be equals to 3.14. Okay, and we need to find the circumference, which is equals to 2 pi r, that will be 2 multiplied by 3.14 multiplied by 3.14, that gives you 19.72 centimeters. Okay, there are three significant figures in this in the radius, so we can have the final answer to be 19.7. Okay, so 19.7 centimeter is the final. Okay, the distance between the 2 points is measured as 2.784 2.784843. Okay, this is to be rounded off to 4 significant figures, hence the value of the distance should be given as, in the entire digit there are 4 significant figures, and hence the answer comes out the distance should be 2.784. But because after 4 there is an 8 which is greater than 5, so this 4 will increase the value. So in order to remove this value we have to increase the value of 4 by 1 number, so your answer should be 2.785. Okay, in order to round off the figure, so the distance should be written as 2.785 meters. Zero error is included in the category of personal error, instrumental error, accidental errors or constant errors. It can't be in personal errors, neither in accidental errors nor in constant errors, so it has to be in the instrument error. So the instrument which we are using must be having some zero errors and we have to correct it. So the correct option is instrumental error. Okay, so the least count of a stopwatch is 0.23. A student found that a time taken for 24 oscillations of a simple pendulum is 50 seconds. So what will be the percentage error in the measurement of the time? So we need to find the percentage error if we have a least count of 0.23 seconds. Okay, so for that 0.2 seconds, it is not 23, it is 0.2 seconds. So we have the formula for percentage error, which is equals to delta t upon t. So delta t being our 0.2, the time taken is for 50 oscillations, so the answer into multiplied by 100 we calculate the percentage, so the percentage error is 0.4%. Okay, so B is the correct option. Okay, so a student obtained a value of Young's modulus of steel as 1.9 into 10 raised to 11 Newton meter square, while the standard value is 2.1 to 10 raised to 11 Newton per meter square. What is the percentage error in this measurement? So again we need to find the percentage error, but here you are giving is the standard value and the calculator of the experimental value. Okay, so we are given the standard value to be, standard value is given to be 2.1 into 10 raised to 11 Newton per meter square, and the experimental value to be given is 1.9 into 10 raised to 11 Newton per meter square. Okay, so we are calculating the percentage error, that is equals to, the formula comes out to be standard value minus the experimental value upon, we have the standard value again multiplied by 100. Okay, so again the standard value is about 2.1 into 10 raised to 11 minus we have 1.9 into 10 raised to 11 upon again 2.1 into 10 raised to 11 into 100. So on solving this we can get 2.1 minus 1.9 into 10 to the power 11 upon 2.1 into 10 to 11 into 100. So the solving gives you the value 0.2 upon 2.1 into 100, which will be about 9.5 percentage. Okay, so your correct option is B, 9.5 percentage. Which of the following pairs have the same dimensions? Torque and force, energy and acceleration, light year and wavelength, and velocity and momentum. Okay, here the torque and force, where torque, which is the force acting, and force, which is mass into acceleration, both have different dimensions. Energy and acceleration, again energy, it is a different dimension, and acceleration, meter per second square, another direction. Light year and wavelength, both are the distances which are to be calculated. Both are used to measure the lengths. So here for the light year and the distance and the wavelength, we have only length as 1 and rest of are 0. So again, velocity and momentum, velocity we have meter per second square and meter per second, and momentum again we have a different unit. Okay, so light year and wavelength are the only two pairs in which they have all the same physical quantities. Otherwise the other rest of the three, they have different physical quantities. The dimension of velocity gradient are same as that of frequency, period time, acceleration or angular acceleration. Okay, for the velocity gradient we have dv by dx. Okay, we'll find where d is the velocity upon change in the length. So we'll be finding the dimensions of both of them. In velocity we have meter per second square, meter per second, right? So we have length as 1 and time, because it is per second, it comes up, it becomes -1. So t minus 1 upon dx, x is the length, so we have m0 l1 t raised to 0. If we change this, we bring this up, the l, it goes as m0 l0 t raised to -1. Now this dimension is equivalent to the dimension of frequency, where for the frequency you have 1 upon time t, where only t becomes 1, and after coming it up it becomes again t raised to -1. Okay, so the dimensions of the velocity gradient are equal to the dimensions of that frequency. In the system of units, the unit of force and energy are 10 newtons and 50 joules respectively. What is the unit of length in this system? 3 meters, 5 meters, 7 meters or 10 meters. For the force we have unit m1 l1 t raised to -2, which is equal to 10 newtons. For energy they have given the units m1 l2 t raised to they have given the dimension, we have the dimensions m1 l2 t raised to -2 upon 50, which is equals to 50 joules. Okay, so we'll divide both the equations. Okay, so we'll divide the equation 2 by 1. This is your first equation, this is your second equation. So dividing the second equation by first equation, we have m1 l2 t raised to -2 upon the force, which is m1 l1 t raised to -2. So again, after division we get the mm gets cancelled, so tt also gets cancelled, so l becomes equals to a single term l, which is equals to 50 joules upon 10 newtons, that is 5 meters of length. So the correct option is B, 5 meters. Now the dimension formula for the ratio of angular momentum to the linear momentum is, we need to find the dimension for the ratio of two things, that is for the angular momentum and linear momentum. Angular momentum is given by the formula I omega, where I is equals to the inertia, that is mr square multiplied by omega, which is equals to velocity upon r, omega which is v upon r gets cancelled, so we have mvr as the angular momentum. Next is the linear momentum, which is simple, that is equals to m into v. Okay, so we are going to find the ratio of this two, mvr upon mv. Okay, so mvr upon mv, all we get is m and mv, and v gets cancelled, all we are left with is r, and r is nothing but the radius. So the ratio is m0 l1 t raised to 0. So m0 l1 t raised to 0, D is the correct option. Now, the density of a substance in CGS is 0.475 grams per centimeter cube. So what is the value in SI system? So we have to find the units and change the value into SI system. Okay, the value given is 0.475 gram per centimeter cube. Okay, so 0.475 we keep it as it is. This gram is in CGS system, and centimeter also, centimeter gram seconds. We have to complete it in SI system, where we have SI MKS system, meters, kilograms and seconds. So the gram will now change into kilograms, and we have 10 raised to minus 3 kgs. Gram, 1 gram changes to 10 raised to minus 3 kgs. And then we have we have centimeter cube. Okay, so centimeter changes into meter, that becomes 10 raised to minus 2, and minus 2 ka cube, that becomes 10 raised to minus 3, minus 3 to the 6. Okay, so that becomes 6 meter cube. Okay, so here it is centimeter, you are changing it into meter, that becomes 1 centimeter, that is equals to 10 raised to minus 2 meters. Because it is a cube of here, so 10 raised to minus 2 the whole cube, that becomes 10 raised to minus 6 meter cube. Okay, now you just change the dimensions. Here if you divide this thing, it will become it will give you the value of about 475 kilogram per meter cube. Okay, it is 475 kilogram per meter cube. So the correct option is B, 475 kg per meter cube. Which of the following is a dimensional quantity? Relative density, no dimensional, and which of the following is a dimensional constant? Okay, so the value has to be a constant. Dielectric constant, no, not dimensionally constant. Refractive index, again mu has no dimension, so relative density, no dimensional constant. Gravitational constant is a dimensional constant because it has got a value for that constant. Okay, so gravitational constant among the four of them is a dimensional constant. What is the length of the arc of a circle of radius 30 cm with substance and angle pi by 6 at its center? 11.7 cm, 14.7 cm, 16.7 cm, or 15.7 cm. So we need to find the length of the arc of a circle of a radius 30 cm. So what we have given is, we have given theta, that is pi upon 6. Also r, the radius is 30 centimeters. Okay, so the relation of this angle with respect to the arc subtended is theta equals to L upon r, where length is the angle, and sorry, where what is the well, L be the length of the arc, r will be 30, and theta will be pi by 6. Okay, so if we inverse this, we get L equals to pi by 6 multiplied by 30, that gives you a value of 15.7 centimeters. Okay, so 15.7 D is the correct option. Okay, the angle of banking theta for a cyclist taking a turn on a curved road of radius r with a velocity v is given by tan theta equals to v upon rg. What is the maximum value of n? Okay, 1, 2, 3 or 4. So firstly we have the formula tan theta, which is equals to v rg with the whole raised to n. Okay, we need to find the value for this n. So we'll go the dimensions way. We'll find the dimensions. As this tan theta it has no dimensions, so it is represented by m0 l0 t raised to 0, and this v is the velocity dimension being m0 l1 t raised to minus 1 the whole raised to n upon r is having only l1, and this g is having l1 and t raised to minus 2. Okay, so if we combine all this, we get m0 l1 t raised to minus 1 the whole raised to n upon, here we can have l2 t raised to minus 2. Okay, so in order to get something mixed outside, we will do this thing, l1 t raised to minus 1 upon power n, and we can remove the 2 out, so this becomes l1 t raised to minus 1 the whole raised to 2. Okay, same thing can be done, and if we equalize this to two things, so what we'll get is l1 t raised to minus 1 raised to n is equals to l1 t raised to minus 1 raised to 2. So both are same, so the n becomes equals to, the value of n becomes equals to 2. So your n is 2, C is the correct option. From the following physical quantities, which is the only quantity which has negative dimension of mass, and linear momentum, force, gravitational constant, or work? Okay, so we will be finding the dimensions for each of the four, and then we'll come to the conclusion which has a negative dimension for mass. So here we are talking about momentum. Okay, linear momentum, and mass into velocity, p equals to, so for that the mass, length and time. Okay, that becomes length is velocity length 1 t raised to minus 2, and mass becomes equals to, sorry, t raised to minus 1. Okay, and mass becomes equals to again 1. So m1 l1 t raised to minus 1. Again for the force, the second option is force, so we have force के लिए meter per second, right? So that becomes m1 l1 t raised to minus 2 meter per, sorry, force is Newton, right? So that will be mass into acceleration. Acceleration is meter per second square, mass, so kg meter per second square. So that becomes m1 l1 t raised to minus 2. Okay, next is the gravitational constant g, whose formula is, we have the formula for force, that is equals to g m1 m2 upon r square. So for the g we can have fr square upon m1 m2, for which the dimensions, if we calculate the dimensions, we'll get, for the force we have m1 t raised to minus 2 multiplied by radius square, that is length ka square, right, upon the 2 times mass, that is m becomes 2. Okay, if we calculate all this, l becomes 3, m becomes 1, m becomes minus 1, and t becomes minus 2. So we got minus 1 as the dimensions for gravitation constant. We'll go on with the work is force into displacement, right? So force into displacement, force is what, m1 l1 t raised to minus 2 into displacement is the distance, that is the length, so that will give you l1, so that gives you m1 l2 t raised to minus 2. So that is your work. Again, work has mass to be a positive dimension, so for the only one thing which we get the negative dimension for the mass is a gravitation constant c. Okay, if the power p, the surface tension t, and the Planck's constant h are arranged in such a way that the dimension of the time in the dimensional formula are in the ascending order, then the correct order is. Okay, so we need to find the dimensions for each of these three and then arrange the time in the ascending order. Arrange the actually dimensions of the time in the ascending order. So we'll go with the power first. That is nothing but work upon time. So that gives you m1 l2 t raised to minus 2 upon time is t raised to 1. So that becomes m1 l2 t raised to minus 3. Okay, so next is the Planck's constant. No, next is the surface tension T, that is force upon length. Okay, force being m1 l1 t raised to minus 2 upon length is only l1, so that gives you m1 l0 t raised to minus 2. Okay, next is the Planck's constant h, which is equals to E upon V. Okay, that is mu will be the frequency. Okay, so that is again E into T, that is 1 upon mu will be the time. So for energy we have m1 l2 t raised to minus 2. Okay, that is nothing but the work done plus energy spent multiplied by t raised to 1, that is the time 1. So that gives you m1 l2 t raised to minus 1. Okay, that will be the Planck's constant. Now in all the three we are taking the time and we are arranging in the ascending order. That means t raised to minus 3 we have out here, t raised to minus 2 we have out here, and then t raised to minus 1. So if we are going to arrange in this way, that is it is decreasing, that is it is increasing in the ascending order. So we have t raised to minus 3 minus 2 minus 1. Okay, so hence the value should be p, t and h. Hence the order should be P, T and H. So P, T and H, B will be the correct option.